So let's take a quick look at dividing with decimals. So if I take the division problem 27 divided by 3 tenths, and as you can see right here, I've written it out in decimal form, but what I want to do is I want to rewrite it in fraction form. And then we remember from doing our fraction division that we're going to keep the 27, change the division sign, and then flip or find the reciprocal of 3 tenths. So it's going to become 27 times 10 over 3. So now what we can do is we can actually do that multiplication problem. I'm just going to write that as 27 over 1. 27 times 10 is 270. 1 times 3 is 3, and now it turns into a straight problem. 270 divided by 3, which is 90. Which we can write right over here, 90. I'll just kind of notice something. 27, 3, and the answer is 90. So let's try another one. 24 divided by 4 tenths. Well, here it is written as a decimal. Let's rewrite it as a fraction. The division problem, when we have it in fraction form, 24 divided by 4 tenths, we keep, we change, we flip. So let's go ahead and do that. Keep the 24, change the 4 tenths to 10 over 4, and we multiply them. So put that over 1. 24 times 10 is 240. 1 times 4 is 4. Oh, that becomes 240 divided by 4, which is 60. And I can now kind of jot that down over here. Oh, and we'll look over here. Look at that, 24. We see a 4, and the answer is 60. All right, let's try one more problem. Remember, we did this one in class also. 36 divided by 9 tenths, which I rewrite as 36 divided by 9 tenths. I want to keep the 36, change it to multiplication, and find the reciprocal of 9 tenths, which is 10 over 9. Now when I go ahead and do the multiplication, just write that over 1. 36 times 10 is 360. 1 times 9 is 9. Now I have the straight division. 360 divided by 9 is 40. And as we then add that to our chart over here, well, what are we noticing is happening? Well, if you recall, 36 divided by 9 is 4, but when we do it divided by 9 tenths, it becomes 40. Well, what's the reason for that? Well, notice this problem really ended up turning into this problem, which means that 36 divided by 9 tenths is the same problem as 360 divided by 9. Now we need to just kind of examine what has gone on. What has happened from here to here? For that, let's take a look at our place value chart. And we know as we move one place to the left, so if we start in the 100th place and we move to the 10th place, we've increased by a power of 10. So when we go to tenths to ones, we're increasing by a power of 10. From ones to tens, a power of 10. And from tens to hundreds, a power of 10. So if you recall, our original problem was 36 divided by 9 tenths. And we said we could end up rewriting that as 360 divided by 9. There's my 9 tenths. There's my 36. Well, if you think about what we did, we took our 9 and we made it in 9 tenths, and we made it into 9 ones. We took our 36 and we made it into 360. So what we did was we built it to higher terms, and it became 360 because 36 hundredths is 360. So in a sense, if we were to think of it this way, we could think of this as a fraction. Whoops, wrong one. We could look at it as 36 divided by 0.9. And what have we done? We've built to higher terms by 10. And it becomes 360 divided by 9. Now, let's go to that next step and look at what 360, where that comes from. So remember we said 36 divided by 9 tenths could be written as 36 divided by 9 tenths, but we could also write it as 36 divided by 9 tenths, but we're not sure. What do we do about this decimal point? So what I want to do is I want to build to higher terms, like I just showed you, and now what I can do is I can rewrite my problem. And instead of showing it as 36 divided by 9 tenths, what I can write it as and show it as is 360 divided by 9. Oops, that didn't work. So I can write it as 360 divided by 9. And that's a problem that we can do. These are the same problem. This makes sense. So let's look at another way of saying what we did. What we really also could say we did was we took this decimal point and we moved it over. And we took the decimal point that's not there, but is actually there, right? It's really 36 points. And we have taken this decimal point and we have moved it over. Well, when we do that, what do we need to do? We need to slip a 0 in there. So it becomes 360. Let's take that same idea down here with our 56 divided by 8 tenths. Well, if I rewrite it as 56 divided by 8 tenths, like so, build it to our math symbol, the next step that I can do is I can simply build the higher terms right here in the division problem. I'm not going to call it 8 tenths anymore. I'm going to call it 8. How did I do that? I multiplied it or built it to higher terms by 10. Well, if I do that by that power of 10, I can do the same thing with my number 56. Oh, but wait, there's no decimal point there. Oh, but there is a decimal point, right? It's really 56. So now what do? Build it to higher terms by 10. And it becomes 560 because I now have taken that decimal point and moved it over. So my new problem is 560 divided by 8, which is 7D. Let me try one more problem. So if I'm looking here, 921 divided by 3 tenths, slide that over. I'm going to do the same thing here. That imaginary decimal point, put it in, slide it over. I need to build it to higher terms. This was times 10, so I'm going to do times 10 over here. And now I have 9,210 divided by 3. 3 goes into 9 3 times. 3 goes into 2 0 times with 2 left over. 3 into 21 7 times, and then 3 into 0 0 times. Okay, if I rewrite this problem, we could also see this. What if it was 513.6 that I was really doing? And so again, if I build everything to higher terms, times 10 here and times 10 here, now I don't have a 0 to add in. It just becomes 5,136 because I have built it to higher terms by 10. So let's do that division. 6 goes into 51 8 times with 3 left over. 6 goes into 33 5 times with 3 left over. And 6 goes into 36 6 times with none left over. So what does that mean? What that means is that 513.6 divided by 6/10 is equal to, what did we say? 856.